Okay, so I would like welcome all of my good students. We have 14 students on this nice Sunday morning. Indeed, thank you very much for coming today because it's a holiday, but again, we are agreed to come and I really appreciate that. So being a religious day and maybe you can engage in the religious activities after the lecture, hopefully. The thing is that we had to schedule this lecture today because we have a less amount of time. Quite less amount of time is there, but we have much more to be discussed. So that's why we have to now a little bit schedule because by 11th next month, we have to finish all the lectures and we have to take the presentations also. So it's a kind of a challenging task, but again, we'll try to finish off the most important points and with elaborate discussions. And I don't want to cut off anything, want to complete the whole syllabus. So that's why thought of even, suggesting these kind of holidays as well. Okay, right. So what we'll do is now, um, we'll commence the lecture today, and we'll see how we could proceed. Okay, right. What was the last thing that we discussed last week? Hmm? What was the thing that we discussed last week? We discussed several things, isn't it? But what's the main thing we discussed? Last week we discussed the regression assumptions, isn't it? We discussed all the important regression assumptions, particularly the basic assumptions and the tricky assumptions. Right? Hope I think you had gone through the now. In this lecture, the best thing is that you have the video, right? You have the video recording. So I hope you had gone through the video recording and enlightened yourself. You had enlightened yourself. So therefore, uh, we will look into that. And so I think you had looked into that and you have enlightened yourself related to that regression assumptions. Okay, regression assumptions are really important when it comes to testing whether the regression is okay or not, the OLS regression. If the majority of the assumptions are not met, then you have a problem. You might not use regression as your analytical tool, OLS regression. And after that, we discussed about your group assignment allocation, right? I hope you had gone through the group assignment and also you are aware of what you need to do related to the individual assignment. Under the individual assignment, you have to create your own data set, right? It can be synthetic data. That means you can create your own made up numbers and apply all the SPSS analytics. All the SPSS analytics you can apply for that we are discussing. Then when it comes to the group assignment, you have been allocated basically a research study. A research study has been allocated, and in that research study, you have been given details, right? And you have to read that research study and use the questionnaire or derive the questionnaire out of that research study, conduct the research, collect data, and analyze it and present the findings. So that's what is expected from your group report. Right? I hope now you have gone through these reports carefully, the assignments carefully, the reports carefully, and now you are ready and you have already started. If not started, after the lecture, please have a discussion with your group members because it's a quite heavy task that you have to do. So therefore, plan yourself. any a large task or heavy task, if you're going to do that, what you can do is you can break into small segments and then get it done. You can break it to more small segments and get it done. Okay, so that's what you need to do. That's what you need to do. And I hope you have started it. And if you have any clarifications, you can ask me, right? During the lecture, after the lecture. But I prefer to discuss things during the lecture, and then I can immediately give you solution because my schedule is quite very tight. So therefore, I might not be able to answer your questions out of the lecture, because during the lecture, I have allocated my full focus attention right to the lecture during the lecture, right? And then afterwards, I have several other engagements I have to attend to, and therefore I might not be able to answer those things. So I encourage you to ask any questions during the lecture related to assignments or the study materials, anything. And I'll be very happy to help my good students. Okay. And you can send me a chat message through Teams chat. And if you want to discuss something, then I will take time to discuss that. Because when I'm addressing one group, the other groups also could learn out of them. Okay. Right. So with that, then we'll commence today's proceedings. Very happy to see you all. We have 22 students out of, I don't know how many students, right? I think there are about 50 odd students, but again, right. Today also there might be a small classroom assessment, so be ready. I might be, right? I don't know whether it will be, but there might be a classroom assessment. So be ready for those kind of assessments as well. Okay. So therefore, because in each class, we'll be, I'm supposed to do classroom assessments in each class. So that's a thing that I have to do. But again, due to logistical issues, it might be a little bit difficult. But again, now, since all the students are now joining online with a computer or at least some device, you are connected to the internet, then we can conduct classroom assessments without an issue. Why? Because there's not going to be an issue, because all have the platform and I'll be giving the output, and based on that output, I'll be asking questions. Okay, so today also, based on today's lecture, there might be assessments. So therefore, kindly provide your maximum attention to what we discussed today. And suddenly there might be an assessment, classroom assessment as well. So expect that kind of a assessment suddenly, right? Okay, Rajhan has raised his hand. Rajhan, is it a mistake or do you need to ask a question? Rajhan?
No, sir, it's
Ah,
mistake.
mistake. Okay, okay. No worries, no worries. I'm just vigilant that if you do have any questions, Puta, no problem. Yeah, ask me anytime. Right? Okay. Right. With that, then we'll start today's proceedings. Very happy to see you all, and great to see you all. How are you keeping? Hope you are going through the materials notes. That's also is a project, a large project. Studying is a project. Life is a project indeed. You have to plan it carefully, right? And then execute step by step. Now, for an example, now you might have lived, uh, I'm sure, 20 or more years, at least 20 years in this world. Now, can you live that 20 years within a day? You can't do that. You have achieved a lot, right? You have come to this point because you have achieved a lot. Can you achieve all those things on one single month, one single year? No. Then life is a project, right? Of course, uncertainties, things that are beyond our control might occur. That's correct. But on the other hand, you cannot live a life that you have lived for 20 or more years within 1 year. So it gradually happened, isn't it? We were born and then we were uh, made to read. We were made to go to school, maybe daycare, then school and preschool, school likewise. Then you have then completed your O levels, then A levels, and then you have come to the campus, SAP campus, which is a turning point in your life. And likewise, you came a long journey, a very, very nice journey. And be proud of that, right? Always don't compare yourself with others, right? Maybe at this age, some people might have completed PhD in certain other countries, right? But we are not interested in that. We have to always compare ourselves with ourselves. If you are going to compare with someone else, then that's someone else. We can be inspired, of course, but not to compare and be depressed. No, never. Our life is our own. And if we take a significant step today, that's a huge victory. That's a huge victory for us. Now, for an example, if you had studied 5 minutes, let's say, not 5 minutes, half an hour yesterday, and if you study 45 minutes, additional 15 minutes today, that's a significant improvement. That's a significant improvement. So you can be happy that you improved. Yesterday, 30 minutes, today I studied 45 minutes. But then if you are going to compare with a person who studies all the day, like 10 hours per day, then you might be disappointed. So you don't need to do that. You can be inspired by looking at people who are studying 10 hours, 15 hours, but again, you have to see whether that's productive. But on the other hand, what you could do is, Kuta, you could see your own progress. Your own progress. Compare your own progress. Track your own progress. So just take an Excel sheet and write down how many minutes you study, right? Likewise, just track your progress, and that will help you to achieve very big targets. So if you are trying to do things in one particular moment or within a week, it won't work. That's why life is a project, your assignments are a project, studies is a project, right? Studies, that's as a component is a project. So plan it and execute step by step. Now, if I take you a large assignment, group assignment, first thing what would I have done is I would have taken a group meeting and allocated the work. If I'm the group leader, I would have allocated the work. Okay, you look at this side, this side, this side, this side, and then have regular meetings. Every maybe 3 days time, we are going to meet and we are going to see the progress and we are going to discuss, right? And then we are going to consolidate that, because I'll be asking questions from all the members. So they have to understand what, because it's not a group work. No? So group work individually as well as group, as a group, you have to take the responsibility as well as you have to explain it. So therefore, you have enough time. The thing is, you have to spend it very carefully and you have to spend it in a productive way. So I'm re-emphasizing because the group assignment has almost 30% weight, 20% for the assignment, the presentation, and 10% for the report. So therefore, please kindly allocate time. And it's a good way that now you don't need to physically meet. Even today's lecture, we are doing it online. So you don't need to physically meet. The only thing is you have to have a good group. And of course, here we have all students who are interested in completing their group assignment and studies. So, and you are some motivated, very good students. That's what I see. Okay, so good luck with your assignment. Good luck with your planning, and execute step by step. Then once you have allocated, then monitor the progress. Monitor the progress every 3 days time. You can take meetings and see what's the progress. Maybe 20-minute meeting, that's it. And see what has been done and not been done. What are the bottlenecks? What are the clarifications you need? How the first planning meeting itself, you can discuss how you are going to execute this project and who will be responsible for what and what tasks, like this. Okay, so please kindly pay attention to that. Right. Okay, with that words, we'll then see what we are going to discuss today. Today, we are going to discuss the test of differences. Now, so far, what we have discussed about basic SPSS manipulations. We discussed about that. It was a very nice discussion that we had, right? And then about starting SPSS, entering data into SPSS, importing data into SPSS. Likewise, we discussed several things and we had revisions as well. because two batches had to be combined. Then afterwards, we discussed descriptive statistics. What did we do under descriptive statistics? We described the sample, isn't it? Then we came into correlation analysis. What did we do under correlation analysis? We looked at the relationship. We look at the relationship between variables, right? So while descriptive statistics, we take one variable and describe that. So it's called univariate analysis. Then we did see the relation under correlation analysis between two variables, right? That was called what? A bivariate analysis, because we take two variables. Then in the third one, in the third main analysis that we did, we discussed about what? We discussed about what? We discussed about what? What was the third analysis that we discussed?
Regression analysis.
Yeah, Nalin, got a call and I told her I'm in lecture. Lecture එකක ඉන්නවා කියලා කිව්වා. So, right. Thank you, Buddha. Thank you for indicating that. කරුණාසේන කියලා පුතේ කත උස්සලා තියෙනවා. Buddha, any question? Maybe I did same thing. Maybe you were not able. I was not audible. Maybe I think that's right.
Yes, sir.
Okay.
Two things. Good morning, sir.
Good morning. Good morning. Happy to see you, Buddha. Okay.
Sir, regarding the classroom assessment,
Yes.
is it live assessment or are you going to give us some time?
It's live, Buddha. Live. I'm going to give you 10 minutes, indeed. 10 minutes දෙනවා. එතකොට අපි lecture එක කරලා ඊට පස්සේ පුතා 10 minutes දෙනවා assessment එක ඇටියට. එතකොට that 10 minutes you have to do that. That's what is meant by classroom assessment, isn't it? During the class, we have to do that. So
Okay, sir.
then we have the individual assignment. That one, Puta, you can do it leisurely at home. Then group assignment also, Puta, that's you do leisurely at home. And classroom assessment is done during the class in a given time.
Okay, sir.
Alright.
Because some of our students, because we are joining from different countries, some of our group members cannot join. That's what I asked, because this will impact to our individual assessment or not.
Yeah, it will. It will. That's why, Buddha, it's expected because we have not been told now. Last time when we did research methodology, we were given instructions to take into consideration. But this time, Buddha, we have not been given any instruction because we have to understand there are two batches here. So therefore, you are supposed to join. That's what I've told. Because last
Yes.
time when we did a research methodology, there were specific instructions given that there are certain students joining from different countries. And therefore, we might need to think of the assignments and the classroom assessments. But this time, no any instruction given. And what I was told is that you do the classroom assessments, you do the lectures, you do the assessments, and we need the marks. And so that's the instruction given this time. So therefore, we'll see. And these classroom assessments, again, what I'll be doing is I'll be giving you several classroom assessments, and therefore, then I'll be taking few out of that.
Okay,
Right?
sir.
So
If you
that's how
can
it's
give
looking.
some flexibility to us to complete the task, because
Then
sir,
the whole, then Puta, the whole purpose is lost. That's the problem. The whole purpose is lost because it has to be a classroom assessment. Do you understand what I'm saying? Because it has to be done on the spot. Classroom එකේදී පුතා දෙන වෙලාවේදී කරන්න. නැත්තම් පුතා ඒක කරනවා කියලා කියන්නේ then I have no control over who is doing that and what's being done and what's the outcome of that. That's the whole purpose of classroom assessments. Do you understand what I'm saying? So I am helpless, right? And these people are requesting that I need to do at least 5 classroom assessments, and I'm going to do it during this time. So I don't know how to address that issue, because then we have to remove this component called classroom assessments altogether, and keep only the individual assessment and the group assessment. So we cannot have then something called the classroom assessment, because if we are unable to do it in the classroom, it's not going to be a classroom assessment. Our definition එක පුතා ගැටලුවක් වෙනවා නේ. So but we'll
I
see.
do,
We'll see.
I do
We'll
agree
see.
with you, because some students they are actually joining from office. Even I'm at the office right now, because
No, that's not a problem at all, because the thing is, Puta, we will be doing the lecture, and of course, and I'll be taking, I'll be taking, finally, I'll be taking 5 assessments or even lesser than that maybe, and I'll be taking I do understand to a certain extent, okay, I'll be taking out of that some. So therefore, make sure, Puta, like I'm not going to take all the things and I'm going to take out of that. I'm going to take some out of that. So make sure that you attend the lectures and you do at least some out of that. Do you understand what I'm saying? If not, Puta, it won't be classroom assessments. And also, the definition is upset me. I'm helpless, Puta. I'm really helpless to, because to comply with the requirements. Then, on the other hand, there should be some kind of instructions given to us, to the lecturers. Okay, no classroom assessment for this batch or something like that. But it's not given. We are being asked to execute the same syllabus to all the students. But I do understand. Now, when I did the research methodology, Puta, you saw that it was a different mode of operation. But this one, I am not given any instructions there. So we'll see. We'll see. I do understand the practical difficulties and other things. But again, we will see what we could do. And we'll explore some certain strategies, what could be done. But again, I am compelled to do the classroom assessments because it's a requirement under the syllabus. So ඒක තමයි තියෙන ප්‍රශ්නේ මට තේරෙනවා. I do understand. But we'll see what could be done. And for the people who are joining overseas at least. But again, we have not been given specific instructions to um, not to give classroom assessments or make any variations for the students who are joining overseas, which was given during the research methodology lecture when I delivered. Because it was for one batch, your batch. So we took that into consideration, and I think you could remember we never gave any assessment. We gave some time afterwards. But
Okay,
now,
so only the consideration, sir, the overseas students actually sometimes they cannot attend the classroom activities because of the time zone. Only that consideration.
I do understand, Buddha.
Other
But that problem, Buddha, I do understand. But that problem, Buddha, we have not been told anything. So Buddha, best
okay,
thing to discuss that with your coordinator. That means the head of the department and the coordinator who is responsible for that, this course, and discuss with that person what could be done. Because there
okay,
should be some kind of for the overseas, because we have not been told anything related to that. So I have not
okay,
been
sir.
given instruction. It's my instruction was given when lecturing to do the classroom assessments and no, but the research methodology lecture when I was doing, I was given specific instructions. I was told that
Mhm.
okay, some students were joining overseas from overseas and things like that. But again, you just discuss with them, so they are also aware about this issue. So, and maybe as a solution, um, what we could do is we could, for these students who are joining overseas, we can have a specific time maybe that to designate a specific time during the lecture, because it has to be classroom assessment, and ask them to join that lecture, join that at least that assessment, and get it done.
Okay, sir. Okay.
That might be an amicable solution, it seems. That might be. So
Okay.
therefore, because to kind of manage this, but again, that's coming from a kind gesture from my side, right? Not that SAB has given me any instructions on that to give kind of specific preference for the overseas students like. But I do understand, Putha. I very well understand that, and I could understand that very well. But again, that is coming from my side as one of my initiatives. Then I will specifically tell a particular time. But at that time, the students will have to come. The overseas students, not the internal students. That means not the students who are working or living in Sri Lanka. The overseas students will have to then put do it. But again, that's also for the people because actually what's being told is that you are supposed to join the lectures.
Okay, sir.
So, and it has to be a classroom assessment likewise. But again, I will see how we can manage this, because it's difficult to manage this, because it's going to be a quite a task to plan it and then execute that, because I have to have different assessments for them. So therefore, it's a little bit of so that's why we'll try our level best to join the lectures, do it, and and complete it. But again, as I told you, I'm not going to take all the assessments that I'm going to give you. I'm going to take maybe few out of that. So
Okay.
that's the last assessment. So that's what I could do, and I could manage the situation. But other than that, Putha, like I do understand there's a difficulty, there's inconvenience, but for us, there's no specific instructions given or a date allocated for the assessments for the foreign students, the students who are joining from the from other countries. So we'll see. We'll see how we could manage this. Okay.
Okay, sir. Okay, sir. Thank
Okay.
you very much for your support.
No problem, no problem. I'll be always looking to, particularly, we do all understand if you're joining from foreign countries. But again, try your level best to join the lecture and do do the assessments accordingly, and we'll see how things are going on. Okay, we'll
Sure,
try
sir. I'll
to.
pass the message also to our students.
Exactly. Please do pass it and try. Thank you very much, Puta, for helping. And we'll try to manage this situation. We'll try to manage this situation, and because no optimal solution is there. But again, we'll try to see what kind of strategies we could use. And so at least I will tell, like, okay, today we are going to have an assessment in the class, so you can enlighten those people, right, the students. And by the way, you don't need to have SPSS or anything. So I'll be displaying certain information, and based on that, you have to answer 10 MCQs or 10 or whatever the number of MCQs. So therefore, it won't be difficult. And so at least to join at that time and do the assessment, and maybe they could leave something. I know it's not the best or the optimal solution, but I think you can help your colleagues who are joining overseas by passing the message. Okay, now be ready for some kind of engagement. Today we'll be having some engagements, and then to join at least for that 10 or 15 minutes, and then quit, something like that. So we'll see different strategies. Okay.
Okay, sir. Okay.
Okay. I'm just thinking about you. I'm thinking how better I could manage this situation and make people okay, that is comfortable, and help my good students. But thank you, Puta, for highlighting that issue. Okay.
Okay, sir. Thank you very much.
Okay, Puta. Thank you very much. Okay, so students, then let's come back. And today, so then I was talking about the correlation analysis. The second analysis, the main category of analysis that we discussed, the correlation analysis. The correlation analysis discussed the relationship between two variables. That's why we call a bivariate analysis. Then we discussed the third type of major analysis, which is the regression analysis. Under the regression analysis, what did we discuss? Under the regression analysis, what did we discuss? So we did discuss anything? No. We discussed. What did we discuss? We discussed on the regression analysis, the impact. We were looking at the impact or prediction, right? Prediction. We tried to predict, right? As well as we could look at the significant variables. What are the significant variables that had a significant impact? I think you can remember in the salary example, the computer programmer's salary example, we tried to see the significant impact. Isn't it? The significant impact. So there we saw that two variables were significant. Computer programmers' aptitude test marks, which reflects their knowledge and their experience, not the membership. The membership did not have an impact on the computer programmer's salary. So likewise, we had these discussions going on, right? These discussions going on, and we were looking at what's going on and how things were there. Okay, right. So today we will see the test of differences. The test of differences. So let me share the screen with you. Test of differences, share the screen with you. Right. So let me reshare that. Okay. So hope you can see my screen. Excellent. Very good. So here you could see this is what we discussed last time, right? Related to regression assumptions, and we had a separate tutorial also on this, and we completed discussing that. So let me close it. And today we are going to discuss test of differences. You can see there's session 5, t-test and ANOVA. So please open that. T-test and ANOVA. Can you see my slide, Puta? T-test and ANOVA. Okay, great. Okay, great. Thank you. Thank you very much. So let's see this one. So session 5, T-test and one-way ANOVA, testing inferences about population means. Here, what we are trying to do is we are trying to look at differences between and among groups related to a certain characteristic. Now, let's say for an example, you want to see whether, now let's take, now in this class we have males and females, right? Male students and female students, girls and boys. So rather than calling them girls and boys, we'll say male students and female students. So let's say I want to see based on a characteristic whether these male students and female students are different. Of course, biologically you are different, that's correct, but I'm not interested in that. Let's say I want to see whether, now let's say IFRS, or let's say research methodology, or let's take this own subject, package-based data analytics. So whether the males and female students are different from each other in terms of the skills on package-based data analytics, on a subject matter, related to a subject matter like IFRS or mathematics or statistics, or even this subject or research methodology, whether the students are different from each other. Whether the students are different from each other, that's what we are trying to see. That's what we are trying to see, whether there is going to be a difference. Okay. Whether there's going to be a difference or not, we are trying to see. So that's what we call the test of differences. The test of differences. Okay. So these test of differences fall into two categories. The first one is test of differences between two groups. If you want to see the difference between two groups. Now, males and females, there are two groups. If you want to compare two groups, we can see the two group difference. For that, we use t-tests. Okay. This is two groups. You are trying to see the difference between two groups. And for that, you use t-test. The independent sample t-test, the paired sample t-test, and the one sample t-test. So these are comparing two groups. Two independent groups, then a paired group, right? Then one sample t-test. So here you are taking two things and you are trying to compare. So for that, we use t-tests. So I have underlined t-test, t-test, t-test. There are three kinds of t-test as you can see. Then the next one you can see is when you want to compare more than two groups. More than two groups. So that's one way ANOVA. And we also could perform post-hoc tests. Right? So this is where when you want to compare more than two groups. Now in this world, you don't have everything, two groups, no? And in Sri Lanka, do you have only two districts? No, right? We have 25 districts. Now, in United States of America, there are 50 districts, right? We call it 50 states. Likewise, what you have to understand is that when there are more than two groups you have to compare, you can use the one-way ANOVA analysis, right? So that you have to keep in mind. So test of differences, where you are going to compare two groups, right? Independent by using independent sample t-test, paired sample t-test, and one sample t-test. Then we will also look at when the situation is there when we have to compare more than two groups. So one-way ANOVA analysis and post-hoc test is a good example for that, right? So we'll see. Now we are going to put all these tests into practice and understand how we are going to perform this test of differences. First of all, let's try to understand what's this independent sample t-test. So there you compare two groups. Let me give you an example. So the independent sample t-test is what we are going to discuss and we'll see. Right. What it does. What it does. It does, as I told you, it compares two groups based on a given attribute, given characteristic. Now let's take an example and try to understand. Then you will understand it very well. Right? Examples is the best way to understand statistics as well as research. Okay, here comes independent sample t-test. Example. Suppose we study the effect of employee training on employee mistakes. Right? We train employees so you can reduce employee mistakes. Two groups of employees who perform similar activities in the same manufacturing plant are selected, and one group is given training. So you go to a factory, and then what you do is you take a set of employees who does the same activity and have similar characteristics, and you give them a training, and you label this group as experimental group, experiment group. And then you take another similar set of employees and you call them, you don't give any training to them, and you call them the control group. Then the mistakes of the two groups are identified separately and reported in the table given below. So here you can see the next slide. Their mistakes. All right. So you can see independent sample data, employee mistakes. The experimental group for the treatment group is there with training, and the control group is there without training. So you don't need to have the exactly similar number because you are going to compare their averages, right? Now, experiment group is where you gave the training. So what you did is you just took how many employees? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 employees from the factory floor on a random basis, and you gave and you call them at 9 employees. You label them, you put them into a group called experiment group, where then you give the training. Then you have another group that you took from the same manufacturing plant. Now there are 10 employees here, and you don't give any training to them. Now these employees are similar, right? But again, the only difference here is one group was given training, the other group was not given training. The group given training is labeled as experiment group or treatment group, and the group who was not given training is named as the control group. Is that clear, Buddha?
Yes.
Very good, very good. Then what we are trying to do is now, right? This is what is required. Indicate whether the training had significantly reduced mistakes of the trained employees. Is the training program effective? As managers, this question comes right all the time, right? So now let's say the scenario is like this. There is a consultant, right, firm who has come to train your employees. Now you have 1,000 employees, and they are now trying to train them. The consultant, the external consultant is trying to train them. But you don't know whether it's effective or not, whether their training program is effective or not to reduce errors, reduce mistakes committed by these employees. Therefore, what you can organize is an experiment like this. Rather than training all 1,000 and understanding that by spending huge amount of money and later on understanding it's not effective, what you will do is an experiment like this. You will take only 19 employees, right? Out of 1,000 employees, 9 employees as the experiment group and 10 employees as the control group to keep them as control. And then you give training only to 9 employees by the consultant. And then what you do is you see whether there's significant reduction in errors compared to the control group. Right? So as sensible managers, you can employ this, right? Employ this technique very well. Even certain drug trials, drug testing also could be done using this method. Right? Okay. So in doing this testing, right, we have two now independent groups. So we can perform the independent sample t-test because we have two independent groups. There are 4 steps always that we'll perform when we do this test of differences. So I'm going to repeat this several times. So you can see there are 4 steps in testing, right? In applying this test of differences. You can see step number 1 is establishing the null height. Establishing the null height. That's step number 1. Then step number 2 is establishing the decision criteria. That's step number 2. Then step number 3, I'll tell what are these, right? Then step number 3, what you'll be doing is you will be using SPSS and calculating the sig value, the p value, the significant value. Then step number 4, right? Finally, you are going to give the conclusion. So likewise, you will understand always we will be performing 4 steps. You will be performing 4 steps in performing this analysis, right? The test of differences analysis on test of differences, 4 steps, right? Now let's apply to our example, right? Establish the null hypothesis. That's the first step. Always when you do test of differences, that will be the first step. Establish the null hypothesis. Null means what? Null means there's no difference. Null. No. Null means no. Hypothesis, the assumption. You assume that there's no difference. So therefore you will write H naught, colon. There is no statistically significant difference between the trained group, that's the experimental group, and the untrained group, that's the control group, in terms of average mistakes. When you compare the average of those 9 employees and the average of those 10 employees, what you say is there's no significant difference. So that's an assumption. That's what we call a null hypothesis. Now, by doing the test, either you will reject this or you will not reject it. Either you reject it or you will not reject it. And that's what you are trying to do. So, on what basis I will reject? That's where step number 2 comes in. Establish the decision criteria. So, what it says is if the sig value, p value is less than 0.05, you reject the null hypothesis. You reject the null hypothesis. You reject the null hypothesis, right? If the sig value or the p value is less than 0.05, you reject the null hypothesis. So that decision criteria will always have to be kept in mind. If the sig value, the significant value, or which is the probability value, which we saw under correlation and regression analysis, is less than 0.05%, you reject the null hypothesis. Keep this in mind. Keep this in mind, right? Memorize that. Less than 5%, reject. Less than 5%, reject. Right? Then what you have to do is, using SPSS, perform the independent sample t-test, because we have 2 independent groups here, the experiment group and the control group, and calculate the p-value. Calculate the sig value of the p-value. Right. And after that, you can come into the conclusion. Now I will tell you what are the steps in performing an independent sample t-test. Did you get a point? So again, now here you have 2 groups, the experiment group and the control group. Only the experiment group was given a training. And what you need to see is now whether the experiment group, the people who were given the training, have significantly lower errors committed on average compared to the control group. That's what you are trying to establish. To establish this, to test this situation, you follow 4 steps. Number 1, you establish the null hypothesis. Number 2, you establish the decision criteria, which is always the same, right? Under null hypothesis, you will say that there's no differences. And the decision criteria, which says, okay, you reject the null hypothesis if the p-value or the sig value is less than 5%, 0.05. And then under step number 3, what you'll be doing is you are going to perform the independent sample t-test. Clear? Shall we do the independent sample t-test? Okay. Is it clear? Okay, good. So I will discard this, right? And then let me go to the... So to do this, you have to open the file called session 5, employee training and without training.sav. Can you see that? Employee training and without training.sav is there. So please open that file. Please double click on that and you can open that file. right? So take some time. Okay, I think it's still starting in your case. I have opened SPSS, so I'm using SPSS every day, right? Or even every minute, I would say. Open SPSS. Okay, I hope you opened it. So you'll see here now you can see the employee number is there for both types of employees. Then you have the number of errors they had committed. Right, it's given in one column, as you can see. Then you can see the groups are there. There are two groups, group 1 and group 2. Group 1 and group 2. Group 1 and group 2 are there. Right? Group 1 and group 2 are there. And what's group 1? How can you know that? Use this value label function. Right? If you click on that, it says, the first 9 are with train. Right? A little bit expand this, then you can see. Then these 10 employees are without train. Sorry. Hello. Did the student want to ask something? Okay. With training and without training, right? You have with training and you have without training. So again, if I press the value labels button, it will be just 1 and 2. And you know how I took that. If you go to the variable view, I have given here under values with training and without training. 1 is with training and 2 is without training. And the first group is with training group. So that's what we call the experiment group, and this the number 2 group is the control group. Right. So that's how it's been structured. Okay. Clear? Okay, very nice. Now this is the structure that you should always have, right? For an independent sample t-test, as well as one-way ANOVA, you will see the same structure. Paired sample t-test, the structure is a bit different. One sample t-test, you compare with a benchmark. So therefore, just keep in mind, this is the structure that you will have for an independent sample t-test. Structure is this. Now let's see how to perform an independent sample t-test. Right now, please take down. This is under step 3, right? I think you can see. Let me take you back. So step 1, establish null hypothesis. So what's the null hypothesis? Here again, there is no statistically significant difference between the trained group and the untrained group in terms of average mistakes. Step number 2, if it is less than 0.05, reject the null hypothesis. Then now we are in step number 3. Using SPSS, we are going to compute the sig value or the p value in this case. So now take down the steps of performing an independent sample t-test. Right? Independent sample t-test, what are the steps? You can see 1 and 2 is there, 1 is there, and 2 is there. Right? How to perform the independent sample t-test is very simple. You go to analyze, or take down the steps, right? Under main step number 3, these are the sub-steps in performing an independent sample t-test. You go to analyze, then you will go to compare means, and then you will go to the independent sample t-test. Independent sample t-test. Analyze, compare means, independent samples t-test. Right? So please take down the steps. Analyze, compare means, independent sample, t-test. Shall I click on that? Are you okay? Okay. Then you will have the usual dialog box that always appears, right? But it's for different purposes indeed. So you can see errors is the test variable. You select the second variable and using this arrow, put it over here. And then group, you put it over here. Grouping variable, you put it over here. And we say define groups. Now, what are the two groups? 1 and 2. So if it has been 0 and 1, then put 0 and 1. 2 and 3, 4, 5, whatever the groups that you are given, you have to give the group number. Here is 1 and 2, so I will say group 1 is 1, group 2 is 2. Right, group 1 and 2, because we have here 1 and 2. And you can press continue. So now SPSS knows what are the two groups. So I just define groups and I type 1 and 2. Right? Is that clear? That's all what you have to do. Okay. Now press OK. You get a nice two tables. What are these nice two tables? You can see with training group, the average mistakes you can see is 9.78. Around, let's say, 10 mistakes on average. With training group had committed 10 mistakes on average. Then without training group, who were kept as control, they have committed 15 mistakes. Right? So average with training, they have committed only 10 mistakes. Without training, they have committed 15 mistakes. Currently, we can see that the training has reduced mistakes, isn't it? But the problem is, yes, we can see there's a difference, but is it statistically significant? Is it statistically significant? Statistically significant. There's a difference, but is it statistically significant? We don't know. To check whether it's statistically significant, that's why we are going to the second table. In the second table, look at the sig value. The sig value is 0.014. So here you can see the sig value. This is the independent sample t-test. This value is 0.014. Right, 0.014. Now record that under the third step. So that's what you do under the third step. In testing the null hypothesis. Right? So I told you if 0.014 is, if this value, if the p-value is less than 0.05, do what? If this value is less than 0.05, do what? Very good. Reject the null hypothesis. Under step number 2, I told you that. By the way, what's the null hypothesis? The null hypothesis indicates there's no significant difference. Now, can you support that? No. It shows here the sig value is 0.014, which is less than 0.05. So you reject the null hypothesis. You reject that there's no difference. That means what? There is a difference, significant difference between these two groups, trained group and untrained group. Right? On the other hand, since there's significant difference, you could say, right, these two groups come from two different populations. Because there's significant difference. Since there's significant difference, you could claim that these two groups come from two different populations. Or simply you could say there's significant difference. Right? So that's what we have done. I have given you the steps in performing the independent sample t-test. And this is the conclusion. As I told you now, rejecting the null hypothesis, the results indicate that there is a statistically significant difference between the mean mistake values between the trained and untrained groups. In other words, the employees have not been drawn from the same population. No, they cannot come from the same population because they are significantly different. The difference between the trained sample mean 9.78 and the mean of the untrained sample 15.10 is so different that it is unlikely that these samples could have been drawn from the same population. It cannot come from the same population because it's significantly different. The training program is thus what? Effective or ineffective? It has significantly reduced the number of errors. Effective than other. Effective. Very good. It's indeed effective. It's indeed effective. So you can see it's indeed effective, and therefore what you can tell is the training program is effective indeed. Right? Okay. Okay. Right. Now let's do an additional exercise. So you will understand it very well. So I'll put exercise. You also put exercise. Exercising is good, isn't it? Exercise කරන එක හොඳයි නේද උදේට? ඔව් සර් දැන් උදේ වරු දැන් වෙලාව කීයද? What's the time? It's 9:32, 1 hour, right? We have just we have done the lecture for 1 hour. So let's do a small exercise. That this is only for your understanding, right? I'm not going to give you any marks. Exercise. For this exercise, let's use an old file that we used in session number 2. Right here in session number 2, you can see that there's a file called what? Survey for ED. There should be a file called survey for ED here. So open this file. Session 2, survey for ED. So I'll say open the SPSS file. Right. Please open this file. Then what you need to do is, right? You don't need this one. Right. Right. Indicate whether male employees are statistically significantly satisfied in life than female employees. But this is what you have to do. You need to see satisfied. Statistically more satisfied. Indicate whether the male employees are statistically more satisfied in life than female employees. So the two variables you have to use is one, the gender, right? Gender will indicate whether they are males or females. And then to see the life satisfaction, you have the total life satisfaction. Right? The gender variable and total life satisfaction variable. Let's call this the gender variable. And this the life satisfaction variable. Right? Total life satisfaction. So these are the two variables, right? Let's say total life satisfaction. Satisfaction variable shows the total life satisfaction. So what we need to see is based on gender, whether the total life satisfaction of male employees are significantly different from female employees. Can you do and tell me? Can you do the test and tell me? Again, apply the 4 steps. Let me tell you how to apply the 4 steps. First of all, establish the null hypothesis. That's H naught. What's the null hypothesis? You would say there's no significant difference, statistically significant difference between male employees and female employees in terms of total life satisfaction. Average total life satisfaction එක සම්බන්ධයෙන් වෙනසක් නැහැ. Based on the average total life satisfaction, there is no difference between the male employees and the female employees. Always you would say the null, no. Then establish the decision criteria. What's the decision criteria? If the sig value or the p value is less than 0.05, reject the null hypothesis. Reject the null hypothesis. So that always you will do. If the sig value or the p value is less than 0.05, you are going to reject the null hypothesis. Right? So that's what you're going to do. Then step number 3, you are going to use SPSS and you are going to perform the independent sample t-test. Why we perform independent sample t-test? Because there are 2 groups, males and females, who are independent from each other. There's no common membership, no? Right? We don't have common membership. So let's see now how you are going to perform the independent sample t-test. So first of all, open that particular file, the survey for ED file. See whether I already opened it. Session 2. Yes. Please open that file. Session 2 survey for ED. Did you locate that? Survey for ED. Right. Survey for ED. Open this file. I hope you have written down the first 2 steps. The first 2 steps is the null hypothesis. That's saying that there's no difference between these 2 groups in terms of total life satisfaction. Right? Then step number 2, decision criteria. Right? If the sig value of the p value is less than 0.05, reject the null hypothesis. This step number 3 is what we are trying to do now. Step number 3. Step number 3 is what? Perform the independent sample t-test. And then compute the estimate, compute the sig value. Shall we do it together? You go to analyze. You go to compare means. And then you will go to what? Independent sample t-test. And as a test variable, you take what? Now, first of all, see how gender, before even going to this, see how gender is coded. Gender, you code 1 male and 2 female, right? 1 male and 2 female. Keep that in mind, right? Okay, then again, let's go to analyze. And you will be going to compare means. And then you will go to independent sample t-test. And then you will take the total life satisfaction variable. You can see total life satisfaction variable is there. Total life satisfaction variable is here. So I put that variable. Then as the grouping variable, what you take? The gender. You put the gender over here and it asks, okay, how the gender is coded. So I will go to define groups and write 1 and 2. Maybe sometimes it's 0 and 1, then put 0 and 1. It's 1 and 2. Continue. That's all. Press OK. Here, males, their satisfaction is 35. 5 to 35 scale, the males have a satisfaction of 20.67. Females have a satisfaction of 22.90. Who are a little bit more satisfied in life. By looking at the mean value, who are a little bit more satisfied? Females, isn't it? Females are a little bit satisfied, but again by 1 Likert point. Males by 20, let's say 2, then females 23. So by 1 Likert scale, the females are a little bit more satisfied. But is it statistically significant? We don't know. That's why we go to the independent sample t-test and look at the p-value, the sig value. Here you can see the sig value is how much? 0.051, isn't it? 0.051. Okay. So my question to you is 0.051 above 0.05? Yes, it is above 0.05. 0.051 is above 0.05. In that case, can you reject the null hypothesis? Can you reject the null hypothesis? You can't. You can't reject the null hypothesis because you will reject the null hypothesis only if it is less than 0.05. Right? So therefore, it's 0.051. It's different from this one, this is the early example. And therefore, you say the conclusion is that, right, the males and females are not different, not statistically different from each other in terms of total life satisfaction. Because you cannot reject the null hypothesis. Null hypothesis says that there's no difference. You cannot reject that. You cannot reject that. So the null hypothesis holds. That means there's no significant difference. There's no significant difference between males and females in terms of their total life satisfaction. Or in the other words, we can say they come from both these samples come from the same population. Right? Same population. If you take certain samples from the same population, there cannot be significant difference. Right? So that's your conclusion. Right? Now let me give another option for you, another opportunity. Okay. Now these for an exercise now. Now do the same for the perceived stress. There's a variable called perceived stress. So let's go back to that survey for ED. And if you go here, there's a variable called TP stress, perceived stress. Can you see whether, based on gender, whether males and females are different from each other based on stress? Whether males are highly stressed or females are highly stressed comparatively? I'm going to give you 2 minutes. Can you check that and tell me? Again, follow the 4 steps. What's the 4 steps? What are the 4 steps? Step number 1. What's step number 1? Establish the null hypothesis. Here, what's the null hypothesis? There is no significant difference between males and female employees in terms of the average stress. Step number 2. What's step number 2? Step number 2, what? Establish the decision criteria. Always the decision criteria will be the same. If the sig value of the p value is less than 0.05, reject the null hypothesis. Reject the null hypothesis. That's step number 2. Okay. Then step number 3. Then let's go to step number 3. What's step number 3? Using SPSS, perform the independent sample t-test. And then see what's the sig value. Then based on that sig value, go to step number 4, which is the conclusion. If the sig value was less than 0.05, you will reject the null hypothesis and say that there is a significant difference. If it is above 0.05, you will say you cannot reject the null hypothesis. Means that you cannot remove or throw away the null hypothesis that says that there is no difference, and you will say that there is no difference based on that. Can you tell me? I will give you about 2 minutes. Can you do the analysis and tell me related to total perceived stress, whether males and females are different? Male employees and female employees in this sample different? Can you tell me? I'm going to give you about 2 or 3 minutes. Okay, what's the outcome? Can anyone tell me? Is there a significant difference? Thank you very much. Excellent. I'm very happy at least one student is giving me the answer. But how about others?
Yes, sir, it's significantly different.
Very good. So who are more stressed? Females or males?
Female?
Males, okay. Okay, we'll check. We'll see whether there's significant difference between males and females in terms of stress. So again, always follow the 4 steps. Step number 1, establish the null hypothesis. What's the null hypothesis? There is no significant difference between males and females in terms of their average stress levels. In terms of their average stress levels, there is no significant difference. Right? So that's step number 1. Then step number 2, establish the what? Decision criteria. Decision criteria is where you say there's no difference. What's the decision criteria? No. You say what? If the p-value or the sig value is less than 0.05, you reject the null hypothesis. So that's the step number 2. Then step number 3, using SPSS, compute the sig value. Let's do it. So you'll go to analyze, compare means, go to the independent sample t-test, and yes, gender is there. There's no problem. Now instead of satisfaction, you are going to put it out and you're going to take the perceived stress. That's all. Gender is coded as 1 and 2. There's no difference. And there's will be total perceived stress. And you are going to press OK. Yes, you can see the stress levels of males is 25.79. But then females, it's 27.42. 2 Likert with almost 2 Likert scale values are higher, right, for females. So it's a significant difference. Yes, you can see here on the sig two-tailed, the p-value or the sig value is less than 0.04. So that's step number 3. is 0.004. Then step number 4. So since this calculated sig value 0.004 is less than 0.05, you do what? You do what? You reject the null hypothesis or not? You reject the null hypothesis because it's less than 0.05. You reject the null hypothesis saying that there's no difference. So you reject that saying no difference. That means there's a difference between male employees and female employees in terms of their stress levels. So you can very well see the stress level of males are quite significantly lower than female employees. So therefore, in this organization, active steps should be taken to reduce stress of female employees. Right? Since there's significant difference, we also could tell in terms of stress, these two types of employees, males employees and female employees, are coming from two different populations. So that's how you would conclude. Okay? That's how you could conclude. They come from two different populations. Okay. Okay, Buddha, is it clear? Very good. Okay. So then I think it's almost 10, right? 9:55 in fact, to be exact. Yes. Shall we take a small break now? We'll take a small break for about 15 minutes, or maybe 20 minutes, right? And shall we meet at 10:15, right? And continue our discussion on the other two types of t-tests. What are those? The paired sample t-test as well as the one sample t-test. So again, two simple t-test. The only thing what you have to do is you have to just perform the t-test, and in all these tests you will see that you follow the same 4 steps. The same 4 steps. Establish the null hypothesis, establish the addition criteria, right? Then calculate the sig value using SPSS, and then step number 4, provide the conclusion based on that sig value. If the sig value is less than 0.05, you reject the null hypothesis. If not, you do not reject the null hypothesis. Reject the null hypothesis means that there is a significant difference. Or in other words, the two samples come from two different populations. If it is above 0.05, you say there's no significant difference, and you would claim that they come from the same population. So that's how you would conclude. Okay, right. So we'll take a small break and we shall meet at 10:15. Right, have your breakfast or whatever and come at 10:15, and we'll discuss the other two types of tests with examples. Right? Okay. Okay, so let's take a break and meet at 10:15. Thank you. Thank you. Okay, students, welcome back. Can you hear me?
Yes, sir.
Okay, Buddha, good. So we discussed about the independent sample t-test. Any questions you want to clarify? Questions, concerns? You know the questions, concerns. Is it clear? No questions, sir, no concerns. Is that so? Okay. Right. Now let me come back to where we were discussing. I also have made your quiz ready. Anytime we'll launch it. Right. Okay. Okay, let me share my screen. Okay, the quiz is ready. We'll do it anytime, right? Okay. Right. Okay. So we will now look at the paired or the dependent sample t-test, right? And we'll try to see what we do under the paired sample t-test. Okay. So under the paired sample t-test, what we try to do is we try to compare again two things, but of the same person or same company. What do you mean? Let me take an example. So this is also called as the dependent sample t-test. Paired sample t-test, the dependent sample t-test is the same. Where is a test of the significance of difference between means of two sets of scores that are related, such as when the same participants are measured in two occasions. So let's take an example. Let's say there are 7 salesmen in Matrix company and they were given mathematics and English tests. Their results are given below in the next slide. Okay. Now you can see the same employee. So let me take this one. You can see the same employee number 1 has done the mathematics test as well as the English test and got marks. So it's not two different persons. The same person who has done the two tests. So that's why it's called a paired sample t-test. It's paired, right? The mathematics marks as well as the English marks are paired by an employee. So that's why we call it a paired sample t-test. It's called a paired sample t-test. So for the second employee also, you can see these two, although there are 2 marks, right? Mathematics marks and English marks, it's paired by an employee. Likewise, it goes on up to 7. 1 to 7 is there. Okay, mathematics test marks as well as English test marks. So this is what we call the paired sample t-test. This is what we call the paired sample t-test, right? So here, now earlier it was males and females, 2 totally separate groups. Here we have 2 marks, right, for mathematics and English, but paired by an employee. So that's why we see here there is a paired sample situation. Okay. So now let's try to take an example, the same example here, and try to see how to perform a paired sample t-test and see whether the mathematics marks on average is better than or significantly higher than English marks, or English marks on average is significantly higher than mathematics marks. So that's what we are trying to do. Okay. So again, you will have the same 4 steps. How many steps are there, Buddha? Very good. The same 4 steps are there. Same steps, 4 steps are there. So step number 1, there is no statistically significant difference between the average mean marks, right, mathematics marks and average mean English marks of the employees. There is no significant difference. Null hypothesis always says there is no difference. In test of differences, null hypothesis indicates there is no difference, right? Then decision criteria. The same decision criteria we are going to use. If the sig value is less than 0.05, we reject the null hypothesis. Always reject that, right? That's what you have to keep in mind. Less than 0.05, you reject the null hypothesis that there's no, you reject. That means there's a difference. Then in step number 3.
Excuse me, sir.
Yes, Buddha?
Sir, in here, we use this paired sample t-tests when we have dependent samples, no? So in
Yeah.
the example, what are our dependent sample, that is maths test and English test results?
Exactly. Exactly. These are the dependents. We have 2 samples in terms of marks. Absolutely. You are correct.
Okay, sir, thank you.
Very good question. So these are the, it depends on these two, marks, depends on what they employ. Very good, very good question. So now we know the first 2 steps, and now let's see how to use SPSS to perform the paired sample t-test. Or as one student very correctly said, the dependent sample t-test. Because we have 2 dependent samples in this case, as the student very correctly asked. Right? Thank you for that question. Okay, so now let's see how to perform the paired sample t-test using SPSS. For that, of course, what you need to do is first of all, go to your downloaded files, where you have all your downloaded files, and you can go to session 5. And you will see that there is employee mathematics and English. Right. Employee session 5, employee mathematics and English. So double click on that and open it. So this is the file that I was talking about. Same thing on the slide that you saw. So the employee numbers are there 1 to 7, mathematics marks and English marks are given. Now we want to see whether these 2 samples, right, are significantly different from each other, which are paired. These are paired by an employee, as you can see. Okay, now write down under step number 3, the steps to perform a paired sample t-test. What are the steps you would perform to do a paired sample t-test? What you do? You go to analyze, compare means, then you will go to the paired sample t-test. Again, you will go to analyze, compare means, then you go to paired sample t-test. So please take down these steps, right? Analyze, compare means, paired sample t-test. Then you put mathematics marks. Then you click on English marks and use this arrow, then it will come to the next. Or you can drag and drop if you want. So mathematics marks and English marks are there. Great. And you will press OK. Okay. Now a nice table appears. You can see tables appears, right? Appear. Okay. And then you can see paired sample statistics. So you can see mathematics average 52 out of 100. They have got almost 53 marks. English result, they have got 45. So there's 8 mark difference. Is it significant? We don't know. To see that, we go to the paired sample t-test table, the last table, and indeed, what it shows? It shows what? 0.010, isn't it? 0.010. So is it 0.010? Is it less than 0.05? It is indeed. So in that case, you reject the null hypothesis. What's the null hypothesis? There's no difference. So you reject that, meaning there's a difference, right? So in that case, what I will say is, yes, English average marks is statistically significantly lower than the mathematics average marks. English marks is 45. Mathematics marks is 52 on average. So 45 is significantly lower than mathematics marks. Earlier, the null hypothesis indicated there is no difference, but there is indeed a difference, right? We can ask the same question like this. Let's say, in the examinations, usually task like this. Okay, now I am doing the steps, and finally I have given. We reject the null hypothesis that the mathematics results and the English results come from the same population. No, they come from different population in terms of skills. Same employee, but their skills are in two different populations. The difference between the mathematics results mean 52.86 and the mean of the English result 45 is so different that it is unlikely that these samples could have been drawn from the same population. No, they are in skills, they are different. The employees have scored statistically significantly lesser in English rather than mathematics, right? English result is 45. So that's what it says. This same question could be asked like this, right? Question. A question can be asked. Statement. A statement can be given like this. There is a manager statement, or you can say like this. A manager states that this is the thing what that person says. Employees, mathematics ability, and English ability. Mathematics. English ability. It's not different. Ability is different. Do you agree with the above statement? Do you agree with that statement? Hmm? One, yes. Or you could say agree. Two, no. So it's agree. Disagree. Yes. And I do not. What's the answer? So what the manager says, the employee's mathematics ability and English ability is not different. Not different. Do you agree with this statement? You can't agree because why? It clearly states under this one, right? The null hypothesis is rejected. Null hypothesis means there's no difference. You reject that. Therefore, the managers claim that the mathematics and English ability is not different. right? You can't agree. You disagree with this statement, right? Why? Not different කියන එක, it shows it different, statistically significant different. So the manager says there's no difference, so you cannot agree with that statement. Okay. So in the quiz that you're going to get, these type of questions will be there. Right? So you have to follow the 4 steps, and based on the conclusion, you have to see whether you can agree with the statement of the given statement or not. Right? Clear? Okay. Okay. Now if I ask this same question, right? Okay. We'll do a small example now. So another question, right? Use session 2 survey for ED file, the file, and see whether the positive effect and the negative effect of the same employee is different or not. What's that? Let's go to that file first of all. Let's go to session 2 survey for ED. And you will see that in this file, down here, there are 2 variables. For each employee, they have measured 2 variables. One is called total positive effect. The other one is called total negative effect. What does it mean? Simply it means, like, positive effect means positive moods. We are asking the employees, do you have positive moods? Like helpfulness, happiness, satisfaction. Those are all helpful moods, positive moods. Then we have negative moods like hatred, anger, jealousy. Those are negative moods. So in a 5 to 35 scale, they have measured that. And now they want to see, now for each employee, they have measured this. Now, if you go to the data set, 127, you can see it's the data set. They have taken the positive mood as well as the negative mood for the same employee. Is employee number 1. Now, the positive mood is 36, right? And the negative mood is 15. You can see there's a difference, right, of the same employee. Fortunately, the positive mood, because in the same person, you can have positive mood sometimes as well as negative mood sometimes. But here it's asked, okay, in the majority of the time, what do you have? So for this employee, it's the majority of the time, the positive moods are there. Sometimes they have the negative moods as well. Likewise, it has for the same employee, they have measured the positive mood as well as the negative moods, positive effect and the negative effect, which is an HR concept. Right? Now the question is whether there's a significant difference between the positive moods and the negative moods of the same employees. Right? So how you are going to test that? Are you going to use a independent sample t-test? No, you should not choose an independent sample t-test. Why? Because these are 2 separate employees. No, it's the same employees' moods. If these are 2 separate set of employees, then you could have used the independent sample t-test. But here you can see it's the same employee having 2 moods, positive mood and negative mood. So in this case, what we have to perform is what? The paired sample t-test or the dependent sample t-test. So how would you do that? So in performing this t-test, again follow the 4 steps. What's the step number 1? What's step number 1? Step number 1 is what? Very good. So step number 1 is this. Establish the null hypothesis. You will say there's no statistically significant difference between the positive moods and the negative moods, or positive effect or negative effect, right, of these employees. Then what's step number 2? Decision criteria. The decision criteria is if the sig value or the p value is less than 0.05, reject the null hypothesis. Then step number 3, using SPSS, compute, right, perform the paired sample t-test or the dependent sample t-test and compute the p value or the sig value. Right? Shall we do that? Yes, let's go to the dataset. Session 2 survey for ED. And you go to analyze, compare means. Then you will go to now the paired sample t-test because it's paired. Go to the paired sample t-test. And now let me navigate down, 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 down. Then you can see here total positive effect. Then you have total negative effect, positive effect and negative effect. And you can press OK. And you will get the result. This is the result. You can see on average, the positive moods is 33. My goodness, that's good, around 34. And negative effect is 19. That's really good. They have, on average, the same employees have lesser negative effect, right? Negative moods. 34 and 19. Significantly different. That's good. Right? But again, whether it's significantly different, we don't know. For that, we can see the paired sample t-test. Indeed, it's 0.0000. Right? Is 0.000 less than 0.05?
Yes, sir.
Yes, indeed. Very good. So what can you do? Can you reject the null hypothesis? Can you reject the null hypothesis? Yes, indeed. Yes, indeed. You reject the null hypothesis. You reject that the positive moods are no different than negative moods. You reject that. So you reject that and you cannot say that these moods, these employees in terms of moods come from the same population because although it's the same thing, the moods are coming from two different populations, right? And yes, there's a significant difference. Now, in this case, if I ask the same question, let's put the same question out here and ask you that. A manager states that employees' moods, positive moods, employees' positive moods and negative moods is not different. Do you agree with the above statement? The manager says that's not different. Do you agree? Clearly, the statistics test indicate what? There's significant difference. So can you agree with the statement?
No, sir.
Can you agree? You can't. No. Answer for this one is also no. Right? So likewise, you will be asked like in the quiz, these type of questions will be there. You have to look at the output. The output will be given. And then you'll be asked whether you agree with the manager's statement. So follow those 4 steps and see whether what's the situation. And based on that, whether you can agree with the manager's statement or not. Okay. Right. Okay. Then before going to the one sample t-test, which is the remaining thing, I think high time we can do the quiz, isn't it? So what I'll do is now I'll share the quiz link to all of you. Any questions before we go for the quiz? All right. So let me put that to the chat. Quiz. Nalin, did you want to tell something? Nalin? What about Madhubuda? Yes. What about Nalin? Kadi. Nalin කියන බලන්න. You can tell.
Can you give the link to the LMS because people we don't have access to the chat.
chat එකේ chat එකට මේව නෑනේ. Okay. I'll I'll put that in the LMS as well. Okay. Then to be fair to all, I'll put that into the LMS. Chat එකකට දාන්නම් පස්සේ LMS එකට දාන්න. Okay පුතා. By all means, of course. So so this is the quiz link, in fact. Copy that. So let me go to your batch. So I'm going to get 16D, right, website. So all have access to that. EXP, package-based data analytics. Okay. So I'll put it on the top, lazy never. Online quiz 1. On the other online quiz 2. තද කරන්න එපා, right? Still don't click on that because it will take you to a whole quiz. I'll hide it till I make the changes. So I'll make it quiz 2 and let me test it myself. First of all, let me test it. Edit. Okay. Right. So this is the quiz link. And I'll press save. And first let me test it myself. Few simple questions, so don't worry. Right. Online quiz 2. Yeah. And let's see whether this output is also working. Great. Right. Now, Bhuta, let me share the things with you. Okay. Right. I'm going to make quiz 2 visible. So please refresh your screen. And you can press online quiz 2 and you can enter the quiz. If you cannot see that, refresh the screen. And I will put that to the chat as well. So yes, it's in the chat. Now it's 10:44 and I will give you till 11 minutes, 10:55. Actually, it will consume 5 minutes, but again, I'm going to give you 11 minutes. At 10:55, we are going to finish it. So go to the LMS and click on online quiz 2. If you cannot see online quiz 2, refresh the screen, refresh the web, the browser, and you will see that. Then once you go to the test, right? So let me go to the test. Please give your numbers properly, name and the number. And then there will be, first of all, the PDF file, right, with the SPSS outputs. So click on that, then it will take you to, and you can download it if you want, or you can open it in another tab. And then you can see that there are certain outputs given. Now, these are about internship satisfaction based on gender of students, then based on the degree program, but the year of the degree program, third year or fourth year, and the major of study, business major, non-business major, likewise it goes on. And then based on that, there will be certain MCQs, some simple MCQs. So I don't think it's going to be difficult. Good luck. 4 minutes more. Okay, 1 minute more. Okay, the time is up. Okay, the time is up. Thank you. Right. I close the quiz. And yes, I'm very happy. Some students have got very good marks. Right. Now, not to show, because I don't want to create any problems for students. So I'm going to take the students who have got 6 out of 6 and 5 out of 6. Right. So let me share my screen. Right. So you can see my screen.
Yes, we can see.
Okay, but I'm good. So here, these are the students who got, and the student has even submitted at 10:49. Right. Extremely good. And so December in Mahalekam, Savitri, Dilshani. Then those students have got, I did not sort it, but you can see. Then then some students have got 5 out of 6. Good. Rujhan, Ushani, 5 out of 6. Then Rajakaruna, 5 out of 6. Then 6 out of 6, Ruvali, Pushpika. Then Devindi, 5 out of 6. Abdullah, 5 out of 6. Sivapriyan, 6 out of 6. Then Sanjeeva, 6 out of 6. Danushka Pereira, Ashan, Danushka Pereira, 6 out of 6. Then Dilum Sandarwan, so 5 out of 6. Then Jayavikram, 6 out of 6. Very good. Then Mohammed. Mohammed has got 5 out of 6. So extremely good. Meanwhile, there are students. I'm not going to show them, of course, but again, here you can see there are people who have got 1 out of 6 and even 2 out of 6. That's a quite lower number, right? That's where, because these are very simple questions based on what we discussed classroom, what we discussed today. I had just tested it, right? So therefore, Kuta, right, I would really request you to take part actively, study, and but again, as I told you, I'm going to take, although I'm going to give 5 or 6 quizzes, I'm going to take few out of them, right? Maybe the good scores, maybe, I don't know, right? Where the students had performed well. But however, please keep in mind that you need to perform well. You need to perform well. And for that, you have to come for the lectures, take part in the lectures properly, and then only because you will be able to do it properly. Because finally, at the exam, final exam, uh, you will be in trouble if not. Okay. Okay, I'm going to stop share, and then give me some time. I'm going to now remove the filter. Data, remove filter. Okay. Okay. So we have got your marks. We have got your marks, and we have got the things. So give me a moment till I get it consolidated. Okay. So I'm going to consolidate things together. Right. Now I have got the earlier quiz as well, and then this quiz as well. So let me put that into one sheet. I'm unable to show the marks because there are some students who have got quite low marks. Therefore, I'm not going to show you the things. But meanwhile, some students have done very well. Okay, so let's take this one, this one. This is quiz 2. Okay. Okay, that's quiz 1. This quiz 2. See marks. Okay. Then let's also take the marks for today's quiz. Okay, right. Okay, let's take the marks here. So, scroll left function. Right. Marks up. Okay, so now it's in one place. Okay, that's good. Okay, right. Your marks are now consolidated. Thank you. Okay, we were discussing so far about the test of differences. So let me share my screen again. So we have up to now discussed. I hope you can see my screen.
Yes, sir.
Okay, Putra, good. So we have so far discussed two types of t-test. T-tests, right? One is the independent sample t-test, the other one is the paired sample t-test. Under t-test, what remains is the one sample t-test. One sample t-test. Now let's try to understand what is this one sample t-test and how to perform the one sample t-test, right? So we'll see how to perform the one sample t-test, and we can then gather that information and see how we can make decisions. Particularly in quality testing, this one sample t-test comes very important. You know, the example I have taken based on that. So one sample t-test, what it does is it takes the sample mean, the sample average value, and compares with the benchmark value, and then tells whether the sample average is significantly different from that benchmark value. That's what it does. Right? Significantly compares with that value and see whether it's significantly different. So that's what this particular test does. Okay. So let's see the example and let's try to understand what is that. Now let's take this basic example. Okay. Okay. Let's come to this basic example. One sample t-test. Okay. Right. For some reason, my PowerPoint is not working, but again, right. Never mind. So one sample exercise. Let's take this example. Carefully listen, and then you will be able to understand. Let's say I am a bulb manufacturer. Let's say a tube light manufacturer. I am a tube light manufacturer, and I have manufactured 2,000 bulbs. I'm a tube light manufacturer, and I manufactured 2,000 bulbs. But let's say there's a requirement, right? There's a quality requirement. Each of the bulbs should last for 1,000 hours. Burning time 1,000 hours. I have manufactured 2,000 bulbs, and there's a requirement that at least a bulb should last for 1,000 hours. So let's say the standards indicate, the relevant standards indicate that it has to last for 1,000 hours. Okay. And that's what we are going to check. We are going to see whether, these bulbs should last for 1,000 hours. So what can we do? Now to check whether these bulbs should last for 1,000 hours, right? What I'm going to do is, I am going to light all these bulbs for 1,000, light continuously, the 2,000 bulbs continuously, and see whether it will last for 1,000 hours, no? Can you do that? And see then whether the bulb should last for 1,000 hours. ඔක්කොම bulbs 2010 කරලා තියෙනවා. බලනවා ඊට පස්සේ I will light the 2,000 bulbs, all the bulbs, and see whether it would last for 1,000 hours. Good idea. If you do that, you will have nothing to say. If I were you, I wouldn't do that. What I'll do is, I'll take a sample of bulbs and I'll do the one sample t-test. Right? I'll take a sample of bulbs, light them, and see how many hours they would last and perform the one sample t-test. That's what I would do. And I suggest also to you to do the same. If not, you will have nothing to say. You have nothing to say afterwards. If you light all 2,000 bulbs. Bulb දිදාපත්තු කරන මොකක්ද විකුණන්නේ? Right? Therefore, I suggest you to take 10 bulbs out of this sample, light it for till it lasts, and measure the time that it will last. Likewise, you can see in this table, right, which I have highlighted, the lasting time is given. 800 hours, 150 hours, likewise, the number of hours is given, right? 800, 750, 940, likewise, the lasting time is given. Okay? Is that clear? Now, what we are trying to see is whether the lasting time on average is significantly different from 1,000 hours or not. 1,000 hours is, let's say, the benchmark. Okay. So likewise, we are going to check the quality of a particular sample that we derive from a population in a one sample t-test. That's the most widely used application of one sample t-test. Again, you are going to follow the same 4 steps. Again, the 4 same steps. Right? What are the 4 same steps? First of all, establish the null hypothesis. Always establish the null hypothesis. What's the null hypothesis? The null hypothesis says there's no statistically significant difference between the average burning time of the sample bulbs and 1,000 hours. We assume the 1,000 hours to be the population mean, right? These are benchmark, 1,000 hours. We assume at least this bulb should last for 1,000 hours. So we therefore claim that there is no statistically significant difference between the average mean time of these 10 bulbs, sample of bulbs, and the benchmark of 1,000 hours. No difference, right? Same step, no difference. Then what you do is you establish the decision criteria. What's the decision criteria for that? If the sig value is less than 1,000, if the sig value is less than 1,000, what you do? You reject the null hypothesis. You reject the null hypothesis. If the sig value is less than 0.05, as we did for all other situations, right? You reject the null hypothesis. Then third one, what you would do is using SPSS, you would perform the one sample t-test and calculate the sig value, right? As we did for all other situations. So shall we perform a one sample t-test using SPSS for this example? Let's do it together. So you go to your downloaded files, right? And you will see the downloaded files, you will see under session 5, here, light bulb example, light bulb receiving. Session 5, light bulb .save. So double click and open the program. In one column, you have the 10 bulbs lasting time. The first bulb lasted for 800 hours. Likewise, the other bulbs are also indicated. Now, our task is to understand whether these 10 bulbs come from a population of bulbs where it lasts at least 1,000 hours. That's what we are trying to check. Accordingly, we established, right, the 4 steps. What are the 4 steps? Step number 1, establish the null hypothesis. We say the sample mean of these bulbs are no different from 1,000 hours, which is the expected mean of the population. No difference. Null hypothesis. Then step number 2, the decision criteria. Decision criteria says if the sig value or the p value is less than 0.05, reject the null hypothesis. Reject the null hypothesis. Then step number 3, what you do is, using SPSS, perform the one sample t-test. Perform the one sample t-test. How to do that? Very easy. You go to analyze. Now write down the steps. Analyze. Compare means. Now go to one sample t-test. Analyze. Compare means one sample t-test. Okay. Analyze. Compare means one sample t-test. Is it take? Did you take down? Okay. I'm going to click. Very good, Buddha. So I clicked on that. Thank you, Buddha. Then I see that there's life. Life is the bulb life. So put it under test variable. Then the test value is the benchmark, 1,000. So type 1,000. Put the test value as 1,000. Put the test value as 1,000. And press OK. Okay, so you get the output which says the 10 bulbs average lifetime is 867. Right? You take the 10 bulbs. Okay, what it has done is it has taken these 10 bulbs added all and divided by 10. Then the average value had come. It's 867. That's what it indicates. Then it has performed the one sample t-test comparing this 867 with 1000 hours and seen that whether there's significant difference. Any person could say there's a difference, but whether there's significant difference, we don't know. So that you perform the one sample t-test, and you can see here the sig value is how much? 0.002. 0.002. So you are going to indicate that under step number 3. 0.002. Understood? Is it clear?
Yes, sir.
Excellent. Then, Putta, what you do is you go to the conclusion. Now, can you tell me, are you going to reject the null hypothesis or not?
We can reject the null hypothesis.
You are going to reject it. Why? The sig value or the p value is less than 0.05. Really good. Excellent. You are going to reject the null hypothesis. Why? Because this calculated sig value is less than 0.05. So under the decision criteria, we reject it. That means what? Can we consider these 2000 bulbs? And now we had these 2000 bulbs. Now, can we consider these 2000 bulbs are having an average lifetime of 1000 hours? We took a sample out of that 2000 bulbs, 10 bulbs, but based on that sample, what we could say is these bulbs, these 10 bulbs could have never come from, right, a population where the bulbs would last for 1000 hours. We took 10 bulbs and we are projecting that to the 2000 bulbs of what we have produced. But unfortunately, we have to reject the null hypothesis, saying that there's no difference. Indeed, there's a difference. So these bulbs couldn't have come from a population, where the burning time is 1000 hours. That translates into what? These 2000 bulbs are not having a burning time of 1000 hours. Lastly, what we could say is, therefore, these 2000 bulbs are substandard, not good quality. So that's okay. We reject the null hypothesis that the bulbs were drawn from a population in which the average life is 1000 hours. No, it can't happen because the one sample t-test rejected that. The difference between our sample mean 867 and the mean of the population 1000, the expected mean, is so different that it is unlikely that our sample could have been drawn from a population with the average lifetime of 1000 hours. Therefore, the 2000 bulbs manufactured are substandard, not good standard, substandard. Right? Is that clear? So this is what we do in quality testing. We take, now I think you can remember, there were some, for an example, there were some dangerous chemicals available in coconut oil, alpha toxin or something. So what they did was, now if a container was suspect of having alpha toxin, what they do is they take samples. They take samples and they check them. And if the toxin level is more than, right, the average level, right, they can do a one sample t-test and see, right, by taking the sample average, and they could do the one sample t-test with the benchmark, what could be the maximum toxin level that could be. And if it shows, right, if the null hypothesis is rejected, saying that this is substantial, now in this case it was substantially lower, then the null hypothesis, if it is indicates, right, if it is lower, or maybe if it is within the level of toxin level, the maximum level, no difference, or less than, then no problem. But on the other hand, if the t-test indicates that the toxin levels are substantially higher than the accepted level, accepted norm, then we have to reject the entire shipment of coconut oil. if the toxin levels are substantially higher than the given level, accepted level. But on the other hand, if it is substantially lower, the toxin level, that's very good. And then the accepted level. Then, of course, you are going to accept the shipment. If it is in par also, if it is in par, like let's say there's no substantial difference, no significant difference within the acceptable level, then there's no problem. But if the toxins are above the right acceptable level, you have to reject the entire shipment based on the sample that you had taken. This is how you test samples. Okay, you might have thought, what's the test they do? They do this test. Right? For this, they take a lot of samples, not 10. They might take 20, 30 samples and they will test this. Okay, clear? Okay. Now let's do a small additional exercise. Now I told you that you would measure the satisfaction level in a 5 to make it a prashna. Right? It doesn't somehow. Okay, no worries. So you can see, let me like this. So let's say you are going to measure the life satisfaction of employees in a 5 to 35 scale. 5 being highly dissatisfied, 20 is neutral, 7 scale now. 5, 10, 15, 20, 25, 30, and 35. So the midpoint is 20. In a 5 to 35 scale, the midpoint is 20. Now, what you need to do is this. You open that session 2 survey for ED file and choose the life satisfaction variable, total life satisfaction variable, and tell me whether the total life satisfaction of employees is different from, on a significant basis, than the neutral value of 20. Why I have chosen 20? Because it's the middle value. I would see whether the employees are on average about 20, right? About 20, whether their average satisfaction level is about 20 on a significant basis. If it is, then we could conclude that these employees are satisfied in their lives. Right? Can you tell me the answer? So go to that particular file, session 2 survey for ED. Session 2 survey for ED is this file. And if you go to the variable view, you can get life satisfaction is the 124th variable. Total life satisfaction. Can you check and tell me whether the average value of this variable, total life satisfaction, is significantly different from 20? Why I have chosen 20? Because it's the mid value, neutral value. Can you tell me whether it's above significantly or below significantly, lower than significantly than this value, or above significantly than this value? Can you check and tell me? Yeah, I'll give you 5 minutes. Take 5 minutes and do the test and tell me. Again, follow the 4 steps. Again, follow the same 4 steps. Okay, I'll give you 5 minutes. Now it's 11:30, 11:35 till 11:35. I'll give you 5 minutes. Can you please check that? Okay, students, what's your outcome? Can someone tell me whether the average life satisfaction of employees are higher or lower than 20? Significantly higher or significantly lower? Yes, Putha? Higher or lower? Okay, let me see. So step number 1, always follow the 4 steps. Step number 1, you will say what? The null hypothesis. Establish the null hypothesis. So what's the null hypothesis? Let me take and show you what's the null hypothesis. Same 4 steps. Again, what's the null hypothesis? This is the null that was developed earlier for that bulb example, but we can use it for this as well. There's no statistically significant difference between what the average life satisfaction and the neutral value of 20. Right? That's what your null hypothesis. Then establish the decision criteria. The decision criteria is the same. If the p-value or the sig value is less than 0.05, you reject the null hypothesis. Then step number 3, using SPSS, now perform the one sample t-test. The one sample t-test. Shall we do it? Okay, you can go here. You can go to example, and then you can go to analyze. Okay, now let's see how to do the one sample t-test. So you go to analyze. You go to compare means, and you go to the one sample t-test. And then test variable is what? Test variable is what? Total life satisfaction. And the test value is 20. We want to see whether the average life satisfaction is significantly different from 2020. Why? Because it's the neutral value. Then you have a press OK. Let's go to the SPSS output. You can see the mean value is of the total, the average life satisfaction. The average of the total life satisfaction is 22.38. Is it significantly different? Yes. The sig value is 0.0000, which is less than 0.05. So therefore, you will conclude what? The employees are on average significantly satisfied than the neutral value compared to the neutral value. Right? The average life satisfaction is significantly different than the neutral value of 20. So that's your conclusion. Is that clear? Clear. So I used even additional examples and tried to explain what are these 3 t-tests. What are the 3 t-tests that we discussed? What are the 3 tests we discussed? The one sample t-test, the paired sample t-test, and the independent sample t-test. So we call this what? Test of differences. There we always compare 2 things. Right? In the paired sample t-test, we compare 2 subjects. In the independent sample t-test, we compared what? 2 groups. And in the one sample t-test, we compared, right, with a benchmark. The average marks with a benchmark. So always we took 2 things and we did the comparison. Okay. So how many steps we followed in all these examples?
4 steps.
4 steps.
4 steps. Always 4 steps. Keep that in mind. හැම තිස්සෙම මේ 4 තමයි යොදාගන්නේ. Always we will follow. Right. Now, after this, we'll discuss, because in this world, we don't have only two groups always or two things to compare. We might have more than two things to compare. Now, in terms of religions, have you only two religions in this world? Now, world එකේ ලංකාවේ තියෙන ආගම් දෙකක් විතරද? No. We have several religions, isn't it? We have 5 or 6 mainstream religions. So likewise, sometimes we might need to compare among these 3 or more groups, between 2 groups, among 3, 4, 5 groups. Anything more than that. Anything more than 2. That means 3 plus. If you want to compare, then you are going to use something called the one-way ANOVA analysis. What? The one-way ANOVA analysis. So that's what we are going to discuss next. That's also a very interesting analysis. But before we go to that, any questions? Talk is ඕන්නේ ඕන්නේ. සර් අදට ක්විස් හොඳටම ඇති. ඒත් බෞතරයක් ඉල්ලනවා නම් තා ක්විස් එකක් දෙන්න ඕන. මොකද ක්විස් එකක් ඕනද? අනේ සර් මේ ක්විස් නම් එපා. දැනට ඇති. සර් හෙටත් ලෙක්චරේ තියෙනවා. හෙට ක්විස් එකක් දෙන්න. Okay. Right. So in that case, we will consider whether we can have quiz tomorrow. Right. Today, enough quizzes. Isn't it? Other than any other quiz. Quiz ඇද්දද මදිද? යමු. නිහඬතාවයෙන් පෙනී යන්නේ quiz එකක් අවශ්‍ය බවයි. එහෙමද? So අපේ blood pressure එක වැඩි. So අපේ blood pressure එක වැඩි කරන්න තු ඉන්න නේද? ඔය දවසේ මේ අද ඔය දවසක් වෙනවා මේ hospital උත් වහලා. So මේ බීරු කරනවා. Okay. I was just joking, okay? So then Puta, if you are going to have a quiz, it will be tomorrow, right? Again, for 10-15 minutes, we are going to have it. That's it we are going to do, right? So, because I am supposed to give quizzes, then what I'll do is I'll take out of that certain quizzes where the students majority had attended. Okay. I see on average there are about 50 students who are taking this class from both batches. And that's very good. Handsome amount is there. Right. Now let's see the next thing. What we are going to do is we are going to compare when there are more than 2 groups, we have to perform the one-way ANOVA analysis. T-tests are performed to compare 2 things. 2 groups, of course, 2 characteristics with a benchmark, etc. Likewise, we compare 2 things. But on the other hand, when there are more than 2 things, we have to 3 plus things, we have to perform the one-way ANOVA analysis. Here you can see ANOVA stands for, ANOVA is an abbreviation, but a nice abbreviation, ANOVA. Actually, the expanded version is analysis of variance. ANOVA. ANOVA. Analysis of variance. So you can see over here, that's how ANOVA, the term ANOVA has come based on the ANOVA. One way means, because we call it one way, because we take one independent variable. You will understand what's this independent variable. We take one characteristic. Right? We take one characteristic and we try to see whether the groups are different from each other. Right? Now we can take, let's say in this class, we have students from 5 districts. More than 2. Then we can see whether they are English proficiency. Right? Whether the English proficiency is different from each other. So we take one characteristic and we take several groups and we compare. So one independent variable is there. Here the independent variable is English proficiency. And then you are looking at whether the groups are different from each other. Right. Okay. So ANOVA allows us to test hypothesis where you have 3+ groups. More than 3 groups. You can compare. So let's take an example and try to understand. Let's take a very appropriate example at the moment. Coffee. Coffee example. Okay, let's take this coffee example. Now we are going to look at how caffeine impacts productivity. How caffeine impacts productivity. So we take 3 groups now. One group is given coffee, but it doesn't have caffeine. We call it decaffeinated coffee. Right? Decaffeinated coffee. It tastes like coffee. Everything is like coffee, but caffeine is taken off. So it has 0 milligram of caffeine. And these employees, there are how many employees? 5 employees. They produce per hour 2 items, 3 items, 1 item, 4 items, and 2 items. Then there was another group, the second group, which was given 10 milligrams of caffeine. 10 milligrams. And they produced, there are 5 employees. They produced 1, 2, 3, and 1 and 2. That's the second group. Then there's the third group. The third group was given double dose, 20 milligram. Double dose was given. And this group produced 4, 4, 4, 4, and 5, 5. So substantially higher they have produced. Right? So these are 3 independent groups. If we had 2 independent groups, you could have performed the paired sample t-test. 2 independent groups from paired sample t-test perform correct. What the t-test that you perform? What the current t-test trigger? Independent sample t-test. But here you can see, unfortunately or fortunately, there are more than 2 groups. So caffeine levels were given. Coffee was given for these employees, but the caffeine levels differed. Right? The first group was given decaffeinated coffee, 0 milligram of caffeine, 10 milligram of caffeine, as well as 20 milligram of caffeine. Right? And we are now trying to see the productivity levels. We are trying to see whether these employees are significantly different from each other based on their productivity levels. Right? These 3 groups. Right. Now again, if you want to test, right, a hypothesis, you are going to follow again what? The same 4 steps. The same 4 steps could be followed. The same 4 steps could be followed. Right? The same 4 steps could be followed. What are the 4 steps? What are the 4 steps? Step number 1. Establish. Very good. Establish a null hypothesis, which says there is no difference. Isn't it? You would say there is no difference. Right? There is no difference, significant difference among the 3 groups regarding their productivity. What are the 3 groups? 0 milligram, 10 milligram, and 20 milligram caffeine groups. Then step number 2 is what? Establish the decision criteria. Very good. Decision criteria. Very good. So if the sigma value or the p value is less than 0.05, you reject the null hypothesis. Same steps. Then step number 3, using SPSS, perform one-way ANOVA analysis. Right? Using SPSS, perform one-way ANOVA analysis. Now let's go to the particular file, open that file, and perform the one-way ANOVA analysis. So how to do that? You will go to your downloaded files And now you will see that there's a file called session 5, caffeine and productivity. Caffeine and productivity. Can you open that file? You can double click and open that file. Caffeine and productivity. Right? You can see there's a, if you go to the data view, first of all, you can see as we had in the independent sample t-test, right? You can see all the employees are listed in one column. Then their productivity is given in the other column. Again in one column, not like in the paired sample t-test data set. It's in one column. Then you have the groups, group 1, 2, 3. And the groups are, if you go to the value label and click on this, you will see 0 milligram group, 10 milligram group, as well as what? You have 20 milligram group. So it's exactly similar to what? The independent sample t-test productivity, right? The independent sample t-test database. In the independent sample t-test also, you had two groups, the experiment group and the control group, with training and without training. So here there are another additional group you can see, because in the independent sample t-test, you compared only two groups. Here you have how many groups? 3 groups. So if 3 plus groups, you are going to perform the one-way ANOVA analysis. Now you have established the two first steps, the null hypothesis as well as the deletion criteria. So step number 3 is to perform one-way ANOVA analysis, one-way ANOVA, and calculate the p-value or the sig value, the significant value. Shall we do that now? Sarun? Karamu, sir. Anivaryan. Okay. You go to analyze, compare means, and you're going to go to now one-way ANOVA. You're going to go to one-way ANOVA. Analyze, compare means, one-way ANOVA. You click on that. And then you can see the factor is the groups. Factor groups. So level of caffeine groups. Put that under the factor. 0, 10, and 20 milligrams, that's factor. And then go to productivity and put it as under dependent list. That's the test variable. Depending is that. You are going to see, yes, whether productivity level is going to be different. Then don't press OK. It's not yet OK to press OK. Go to options now. Go to options and pick descriptives. Take descriptives. Okay. Then you will see the descriptive statistics. If not, by default, one-way ANOVA analysis doesn't provide descriptives. But here you have to tick it, then it will give the descriptives and press continue. And you can press OK. What you have got here? Nice descriptive table. So it says these are the 3 groups. 0 milligram group. The mean value of productivity is 2.4. About 2 items. 2.4 items. And 10 milligram groups 1.8. 1.8 items. I told you don't say 1.8, but again, it's the productivity on average. Then 20 milligram group, it's 4.39, 4.33, 4.33. So you can see there are differences, but the problem is it is statistically significant. For that, go to the ANOVA table. In the ANOVA table, go to the sig value. Now, what's the sig value? 0.001. Isn't it? 0.001. Do you agree? We have to agree because it's given by SPSS. Yeah. So you can write down it's 0.001. So under step 3. Then step 4. Are you going to reject the null hypothesis? Or can't you reject the null hypothesis?
We can reject the null hypothesis.
Exactly. Very good. We have to reject it because it's less than 0.05. So therefore, you conclude like this. You are very correct. Since the estimated p-value, sig value is less than 0.05, the null hypothesis that there is no difference among the groups in terms of their productivity is rejected on an overall basis. Right? In fact, there are 3 groups now. How many combinations? You can compare the first and second group, first and third group, second and the third group. Likewise, there are several combinations. So group-wise comparisons could be made. But on the other hand, what you say is here, right? Overall, right, the null hypothesis could be rejected. There are differences. Maybe not with all groups, but some groups might be different from each other. That's why always I have used the term overall. So overall. Overall. සමස්තයක් විදිහට ගත්තම differences තියෙනවා. ඒක on an overall basis there could be differences. That's what it says. Significant differences in other, but it doesn't say which groups are different from what, which. Does it say that exactly these groups are different from these? No, it doesn't say. Unfortunately, it doesn't say. Right? But it says overall there are differences. That's why I told overall. On the other hand, if you really want to say individual group-wide differences, because I have given a note here, one-way ANOVA analysis indicates whether differences exist among the groups on an overall basis. But, however, it did not indicate and include whether there are differences between the groups on a separate basis. So if you want to see whether each group is different from each group, the other groups, then you have to perform an analysis called post-hoc analysis. You have to perform something called post-hoc analysis with ANOVA. ANOVA එකත් එක post-hoc analysis කරන්න ඕන to see what groups are exactly different from other groups. Right? Now let me teach you how to perform a post-hoc analysis. How to perform a post-hoc analysis. To do a post-hoc analysis, what you have to do is, right, again go to the same data set, caffeine and productivity, which you just open now. Right? Right? And you can go to analyze, compare means, and you can go to one way, again the same steps. You are going to put the factor is what? Level of caffeine, and dependent level is the productivity. And then go to post-hoc button here. Don't press OK. Of course, I think you can remember we went to options and we took the descriptives. That's good. Leave it as it is. But now under this one, we are going to go to post-hoc. You know the post-hoc here. Can you see that there's something called post-hoc? Post-hoc. Excellent. Go to post-hoc. And there are different kind of post-hoc analysis, but this Tukey, it's not Turkey, it's Tukey's post-hoc analysis is very, very popular. So why not you choose Tukey? Tukey's post-hoc analysis. Tukey's post-hoc analysis. Let's continue. And press OK. Same tables appear, but you see that there's an additional table below. Descriptive statistics again indicates 2.4 for the 0 milligram group. Then 10 milligram group, it's 1.8. 20 milligram group, it's 4.33. Good. ANOVA says, yes, as we saw earlier, there are significant differences among the groups on an overall basis. But it doesn't say what groups are exactly different from each other. Now comes the post-hoc comparison. This table is very, very important. It compares all three combinations. All three combinations. It takes each group and compares with other groups. Now, for an example, look at here. The first group is 0 milligram group. It compares with 10 milligram group as well as 20 milligram group. Now, for an example, it takes 0 milligram group and compares with the 10 milligram group. So here you can see the mean difference is 0.8. How that point? Oh, it's 0.6, isn't it? 0.6. How that 0.6 came up? Now the mean is here. How much? 0 milligram and 10 milligram group. You can see 2.4 and 1.8. The difference is 0.6. So that's how this 0.6 came up here. And then it says whether these 0 and 10 milligram groups are different on a significant basis. So you can see the sig values above 0.05. Right? So is there a difference? No, there is no difference. Because we know the sig value has to be less than 0.05 to say that there's a difference. But how about the other combination? Then it compares 0 milligram group and the 20 milligram group. So the mean difference is 1.83 because you can see 0 is 2.4, 20 milligram group is 4.33. So the mean difference is 1.833. And in fact, 0 milligram group is lower, right? And that's why it's minus here. And is it significant? Is it significant? Yes, indeed, it is significant. You can see the significant value is less than 0.05. You can see the significant value is less than 0.05. In fact, it's less than 0.006. So it's even significant at 1% level. Right. So you can see that therefore, even SPSS has put an asterisk over here if it is significantly different. And the asterisk means the significant level is at 5% level. So there is now you can see, although 0 and 10 milligram groups are not different, 0 and 20 milligram groups are different from each other. Then it makes a comparison with again the same thing sometimes, right? 10 milligram and 0 milligram. So this is the other way around. It took now 10 milligram and compares with the other two groups. Same thing, right? It's -6 now, minus 0.6 now. And again, it's same significant level, it's not different. But how about 10 milligram and 20 milligram group? Yes, again, it shows there's a significant difference. It's 0.001. So here you can see the mean difference is 2.5. Right, 2.5. 0 and 20 milligram. 0 milligram group, 2.4. And then 20 milligram group, 4.33. So 2.5, it's significant difference. You can see an asterisk is also placed. Then 20 milligram and 0 milligram, which we saw earlier, 0 and 20, and here it's repeated. Now you take 20 milligram group and compare with the other two groups. This gives actually the summary. So 0 and 20 milligram groups, 0 milligram group, yes, it's significant different, which we saw here. And then 20 milligram and 10 milligram group, which we saw here above, again, significant different. So it's a repetition that we saw up, of course, there. And we can say, yes, in that case, 20 milligram group is what makes the difference between 0 milligram and 10 milligram groups. But on the other hand, you very clearly saw that 0 and 10 milligram groups are not different. So likewise, you can see what are the groups exactly different from each other. Right? What are the groups exactly different from each other? You can see by performing a post hoc analysis. By performing a post hoc analysis, you can see what are the groups exactly different from each other is what you could see. Is that clear, Buddha? This is the importance of performing a post hoc analysis. The one-way ANOVA analysis, it told in overall there are differences. Here also you can see it showed overall there is a difference. This is the ANOVA table. It shows significant level. Yes, overall there are differences, but to see what groups are different from each other exactly, you perform what? The post hoc analysis. Right? The post hoc analysis. Clear?
Hello, sir.
Very good. Okay.
Hello.
Now, very nice. Yes, Puta.
Yeah, one more thing, sir. Here we can see the minus answers and plus answers. Then is there any, the relationship positive or negative?
No. නෑ. ඒ කියන්නේ පුතා mean value එක මොකද දැන් උදාහරණයක් හිතන්න මේ එකම තිය ඔය කියන්නේ 0 මිලිග්‍රෑම් group එකේ 20 මිලිග්‍රෑම් group එකේ 1.8 difference එකක් තියෙනවා කියලා කියන minus. කියන 0 මිලිග්‍රෑම් group එකේ පුතා mean value එක ඇවිල්ලා 2.4. දැක්කද? ඊට පස්සේ 20 මිලිග්‍රෑම් group එකේ වගේ 4.33. ඒ දෙකේ difference එක තමයි මේ කියන්නේ. එතකොට ඔය 0 එකත් එක්ක මේක compare කරොත් minus වෙනවා එතන. minus 1.8 minus එකක් නේ 1.88. ඒක අර comparison එක කරද්දී එන value එක. ඒකම මෙතන compare කරනවා 20 එකයි 0 එකයි. එතකොට මොකද වෙන්නේ 20 එකනේ වැඩි 20 එකේ වගේ කීයද 4.33 වලින් 0 එක අඩු කරා 2.4. එතකොට ඒකම plus වෙලා තියෙනවා 1.8. ඒක mean difference එක අරන් තියෙන. එහෙම නැත්නම් plus මෙතන relationship බලන්නේ. මෙතන mean එකේ difference එක තමයි බලන්නේ groups අතර.
Okay, sir.
So he asked a very important question. So what's this plus and minus? That's the average value. You take the mean value and then you compare with the two groups. Now, in this case, 0 and 20 milligrams, if we take 0 and 20 milligrams, it's 1.8 minus. Why? Because 0 milligram group, the mean value is 2.4. The 20 milligram is 4.3. So 2.4 minus 4.33, you get minus 1.833. But the same thing, again you compare in the last group comparison, 20 and 0. It became here 1.8 plus because why? The 20 milligram group has 4.33. Now 4.33 is higher than 1.8. So that's what plus sign has come. Not that it's a positive or negative relationship. You don't look at positive or negative relationships in post-hoc analysis. In post-hoc analysis, you don't do that. You are comparing the groups. And post-hoc analysis will tell you what groups are exactly different from each other. Monogroups එකත් එක්ක වෙනස් වෙනවද කියලා හරියටම කියන්නේ post-hoc analysis. Good question, Puta. Thank you. How about others? Right. Okay. So let's now apply our knowledge into our employee example. Okay. And you tell me. Not a quiz, don't worry. Right. Let me give an question. Again, not a quiz, right? Don't worry. Quiz එක දෙන්නේ කියලා. දෙනවා නම් කියලා නැත්නම් quiz එකක් දෙනවා. So let's again use the same example. This example, and then let's use the survey for ED file and let's see. Okay, demographic factors, marital status. But I'm a little bit suspicious with the education level. Let me do a small analysis and see. Marital status, educational, highest education level. You don't need to do this. I'm just checking, right? I'm checking whether we can perform a proper analysis. Okay, yeah. Yeah, no problem. You can perform, right? Okay, now let's see based on whether the marital status, whether the employee satisfaction differs, right? Okay, I'll say the question like this. Whether the total life satisfaction total life satisfaction of employees statistically different based on their marital status. සමහර කියනවා married පුද්ගලයෝ වඩා happy unmarried පුද්ගලයන්ට වඩා. Some people say that whether they some people say that even some research indicates married people are more happy than unmarried people. But sometimes when I see some people, my observation is some people are, if you get a wrong partner, they are in utter hell. If you get the wrong partner, right? Therefore, be very careful when you are going to choose a partner. Sometimes before the marriage, they will be acting in a different way. After marriage, they act in a very different way. Both males and females, I could see. Those are my observations when I say. Therefore, be very careful. Although on average, what it indicates is married people are more satisfied and happy than unmarried people. But there's a big condition there. The condition is that the people who marry should tolerate each other, understand each other, respect each other, and continue their life journey. If not, I have seen utter hell, complete hell. Right? Some people, my God, they are suffering to the core. Suffering to the core. Because I don't know, they don't, now they say perfect match. Can two individuals perfectly match? No, never. You cannot expect perfect matches, right? What you can do is you can have least unmatching things, right? And also actually the secret behind, I think, better marriage is understanding, tolerance, and not to prove that always you are correct or that person is incorrect, but to tolerate and understand, yes, we all are humans and we might have different perspectives. Okay, that's enough about marriage advice, right? Okay, but again, on average, what it shows is people who are married are happy, right? But again, the main condition, again, I'm going to tell you, be extremely careful. Be extremely careful to find a better person, a person who could understand you and who could tolerate you, right? Who could tolerate your behavior and understand it. And don't get deceived by acting. Before marriage, people act. Very good actors and actresses are there. But after that, 360-degree, and I don't know, 180-degree changes we can observe sometimes. Okay, let's keep that aside and see whether based on the marital status. Now, if you go to the data set, again, I'll go to the data set. But again, my best advice is please, if you are in the correct age, if you are, the correct age, and if you are financially and otherwise ready, please get married to a good person, right? That's what my advice is. Okay. Okay. So let's see. Now the education level is there. Oh, no, marital status. Actually, marital status is there. So you have here several marital status, right? There are about 8 types of marital status. Now, what I want to see is this. whether these groups, now singles are there, widows are there, likewise. Now, whether these groups are different from each other, right, based on this marital status, right, life satisfaction. Life, there's a life satisfaction, right? Life satisfaction is different from each other based on the marital groups, right? The marital status. Can you do it and tell me? Now you cannot perform an independent sample t-test because you can see the marital groups are more than 2. You have 8 groups, isn't it? So therefore, you cannot perform an independent sample t-test. You will have to perform one-way ANOVA. And I suggest to do a post-hoc analysis as well. Right? Then you can see what are the groups that are exactly different from each other. Okay. Right, I'm going to give you 5 minutes. Will you perform the test and let me know? What's your conclusion? Are the groups different from each other?
Yes.
Very good. Excellent. So we got the answer from one student. Thank you, Buddha. How about others? Okay, we'll check that. Now, to do this, we'll go to analyze. So again, the 4 steps. Establish the null hypothesis. Null hypothesis, there is no difference among, why? Because there are more than 2 groups, marital groups. So there are no difference among the marital groups in terms of their life satisfaction. Right? No difference. Then step number 2. What's step number 2? Establish the decision criteria. If the sig value or the p value less than 0.05, reject the null hypothesis. That's step number 2. Step number 3 is what we are going to do now. Step number 3, using SPSS, perform the one-way ANOVA analysis plus post-hoc analysis. Or do that? We will go to compare means, one-way ANOVA. And here, what you're going to do is you're going to take the variable. Factor is the marital status. So let's put that marital status is the factor. Right. And then let's take the life satisfaction. Right. Total life satisfaction. The dependent variable. And then we'll see the post-hoc. Right. First of all, go to options and take descriptives. That's it for the normal one-way ANOVA. But then we'll also ask it to do the post-hoc analysis. Go to post-hoc and please select two keys first stock analysis and press continue. Okay. And now just press OK. Very good. Now let's see the satisfaction. Single people, the satisfaction is 20.87 or something. Then steady relationship 22.38. Little bit higher. Then living together 22. Married first time 23. Remarried 24. Okay. Separated 15. Divorced 18. Widowed 27. There are 7 employees who are widowed, 27. They seem extremely happy, isn't it? Okay. But I don't think at all these would reflect, these 7 people would reflect the general population. But again, widow means that you lose your partner, isn't it? For a long time you might live, and then that person might say goodbye to the life, and how can they be satisfied? Maybe then they remarried with the job, right? Job pe karte ka marry karana. Okay, right. Never mind. Now, then the ANOVA table you go and say overall what you can say. Overall the sig level is 0. Now then step number 3. So you using SPSS, you did the one-way ANOVA analysis, right? Then what it says is that the sig value is 0.000, something small. So it's less than 0.05. Therefore, your conclusion is, right, step number 4, that yes, based on the marital status, there are significant differences in terms of life satisfaction on an overall basis. But now to see what groups are different from what exactly, you have performed the Tukey's post-hoc analysis. Here, look at only things that are having this asterisk. Then it's easy. Because those asterisk things are where the sig value is less than 0.05. So, is the single group different from other 7 groups? Single group statistically significant different then? No. It's not different from other 7 groups. How about steady relationship? It's also not different from any other group. Then how about living together? No, it's not also significantly different from any other group. Married first time? You can see married first time group is significantly different from single group. And you can see the mean difference is 2.5. And it's significant because what? The significant level is 0.038, which is less than 0.05. So you can see there is an asterisk for this. And married first time group is higher in terms of their satisfaction because there's a positive 2.5. So research is correct. And then you can see also married first time group is significantly different from separated group. And it has a Likert value of 7, almost 8 higher than in terms of life satisfaction with separate group. Divorce group also same thing. Married first time, yes, even with divorce group, they are very significantly higher. So you can see these married first time group with single as well as separated as well as divorced, they are happier, isn't it? That's what it says. Then remarried group is different from separated group as well as divorced groups, right, in a huge margin, but not different with any other groups. In separated group, of course, we saw married first time, and this is a repetition, isn't it? We saw that in the earlier. Remarried groups are different, and also widow group is different, right? The divorce group is different from this group. Remarried group, we saw that earlier. As well as married for the first time, we saw that earlier as well. And finally, you can see this group, widowed group, is different from this separated group on a significant basis. So you can see under this, some things were repeated, of course, but you can see under the post-hoc analysis, what groups are different from each other, right, on a very specific basis. So that's the importance of doing a post-hoc analysis. You can see what groups are different from each other. Okay. Okay, so that's what I want to discuss today in terms of testing differences. So today, whole day we spent on this, on testing differences between different groups, right? Group-wise differences, 2 groups and more than 2 groups. Yes, I can see one student has raised his hand. Yes, Puta, please go ahead.
Excuse me, sir.
Yes, Puta.
Sir, if you can more elaborate about the group assignment, it's very good.
Okay, very good. Thank you, Puta, for that question. Excellent. Under the group assignment, Daru, what you have to do is very good. Now you have been allocated a research report, isn't it? Group assignment research report. Each individual group has got a group report. Step number 1. Api steps Step number 1.
Okay.
Read it. Yes. I have allocated that to you, no?
Yes, sir. You have already allocated.
Right. So then, Puta, what you need to do is read it very carefully, first of all. Not very carefully, just read it. And then locate the questionnaire. ඊට පස්සේ පුතා ඒකේ සම්මාරයට appendix එකේ දාලා ඇති question එක. නැත්තම් ඒ assignment එක ඇතුලේ පුතා question එක තියෙනවා. You can take the questionnaire in the appendix as well as you might derive the questionnaire as well. Then what you need to do is now you have to collect data from students. No, these are all students. You can you can ask your colleagues. You can ask your other non-state university students, then state university students. Likewise, you can ask them to fill it. Right?
Okay, sir.
But before filling that, Puta, see whether certain questions are appropriate. මේවා පුතා මේ ෆොරින් විශ්වවිද්‍යාල වලට අදාළ මේවනේ ගන්න. එතකොට සමහර විට terminology එක sometimes the terminology not be appropriate.
Okay, sir.
So you might need to put change the amend the terminology. එතකොට ඒක වෙනස් කරන්න වෙයි, questions පොඩක් වෙනස් කරන්න වෙයි. So you can maybe tomorrow Puta, you can ask me. You can show the question.
So we have prepared some questions. If you don't mind, I can show it.
අපි ඒට බලමු.